Okay, Assalamualaikum and very good evening. Okay, my name is Aiman bin Azrul Afandi. So today we will be learning about mechanical basis of human motion. So the learning outcome from this chapter is identify and differentiate Newton's law of motion and identify and differentiate the mechanical behavior of body in contact. So basically we will be learning about the Newton's law. So if you have already know, Newton's law have three parts, which is the law of inertia, law of acceleration, law of reaction, and add on the law of the gravitation. So we will not be learning about the law of gravitation because it is not important. So the first one is the law of inertia. So basically, law of inertia is the law that nobody can change the law unless they find a new thing. It means that if someone can define, I mean not define, if someone can prove that the Newton's law is wrong, then they can change the law. But if not, then there's still the law of inertia. So law of inertia is example, a body will maintain an state of rest or constant velocity unless acted on by an external force that changes the state. Means that if you are I give you an example. If our body is standing straight and then there's no motion, right? But if you are standing on a bus and then the bus suddenly stop, and then your body will move, right? And that is the law of inertia. It means that you're not moving, but the movement around you and the object around you is moving, that makes you move. Okay, so the next law, Newton's law, is the law of acceleration. That is force equal to mass acceleration. Stated here that is a force applied to a body causes an acceleration of that body of a magnitude proportional to the force in the direction of the force and inversely proportional to the body mass. So it means that the greater amount of force applied, then the greater amount of acceleration. So if you hear what I said just now, force equal to mass acceleration, don't focus on the mass, because if you think logically, if your mass is high, then you will not have acceleration, right? So you focus on the acceleration. So the greater amount of the force, and then if your force is greater, if your force is high, and then and your acceleration will be high too. So it state here that, give example, if your force is small, then the acceleration will become small too. But if you double the force, and then the acceleration will be double too. Okay. The next law is the law of friction. So law of friction is simple. Okay, means that one action equal to one reaction. Okay, if you not understand, I'll give you an example. I'll give you a jumping. Okay, jumping movement. If you are jumping, you will push the ground, and then you will go high up the sky, right? So what causes you to so that you can jump? So example, if you are jumping, your jumping is the action, and the reaction is from the ground, so that you can jump. I mean, if our body have uh, new our body have our body our body have energy. So if your body give the ground 3000 energy Newton energy, and then the ground will give you the same amount of energy, so that can cause you to jump. Okay, that's why if you jump on the water will absorb your energy, so that you cannot spring on the water. So next is the mechanical behavior of bodies in contact. We have 4 components, which is friction, momentum, impulse, and impact. So the first one is friction. So basically, friction is a force acting over the area of contact between two surfaces in the direction opposite that of motion or motion tendencies. It means that if in order for you to have friction, you need to have two different surfaces that is moving inversely, not in the same way. If you have like this, I give you an surface A and surface B. If the surface A is moving upward, then the surface B is moving downward, then that is called like this. That is called friction. But if the surface A and surface B moving upward, and then there will be no friction. So next is the momentum. So basically, momentum is equal to mass velocity. Okay, so to simplify the momentum, it says here that a static object with a zero velocity has no momentum, that its momentum equals to zero. A change in body momentum may caused by either change in body mass or change in its velocity. Means that if your body has a high greater mass, then your momentum will be greater. But if let's say you have a great mass, but you have zero velocity, and then that will cause your momentum will be zero. Okay, understand? Okay, next is impulse. Okay, impulse is the same as the momentum, but a little bit different. So by momentum, if your mass is high, and you have velocity, then your momentum will be greater, right? So impulse is inversely by that. Impulse is that if you have small force, and then you have a large time on the surface. Okay, I'll give you an example: lawn ball. So you have you must to in order for you to win, you must roll the ball nearer to the jack ball. Okay, so if you give too much force to the ball, and then your ball will have small time on the ground, so that your ball will pass the jack ball. Okay, so the next example is if you have a large force on a small time. So it says here that baseball, if you want to you want the ball to go over the stadium, you must have a large force to give to the ball. in order for you to uh, in order for you uh, in order for you to make the ball go higher. Okay, so the last one is the impact. So basically it says here that impact, a collision characterized by the exchange of a large force during a small time interval. Example given, a type of collision that occurs between a struck baseball and a bat. So perfectly elastic impact. This impact have two types, that is plasticity and elasticity. So where's the words? Okay. It described as the relatively elasticity of an impact. The closer the coefficient of restitution is to 1, the more elastic is the impact. The closer the coefficient is to 0, the more plastic is the impact. So let's say the maximum you can go is 1 and the minimum you can go is 0. If let's say I give you example of movement that is 0.33, so it's little, right? It's nearer to the 0, then it's the plasticity. But if it's nearer to the 1, then it's elasticity. Elasticity means that if let's say example, okay, you have a ball and then you have three types of ball, of golf ball, a football, and a volleyball, and then you have the same height but the different ground, different surfaces, sorry. So the first surface you have a futsal court, and then the second surface is the football field, and then the last surface is the uh, the sand. So you can see the differences between the velocity after the impact. So the formula is yeah, the coefficient of the restitution equals to the relative velocity after impact divided by the relative velocity before impact. So you can get the impact formula. So that's all for today. Thank you.